Good morning, .NETers. Thursday morning. Appreciate everybody for coming out for this. I am David Dieruff. I am a product marketing manager, all things Windows and .NET at Pivotal. Here with Chris.
Chris Humble. My title this week is the .NET Journey Lead with aptX at Pivotal.
And we're here to talk about .NET. I'm going to give the Java folks a chance to
go for the door.
Okay, good. Okay, we're good. Right, so today we are talking about legacy .NET and Kubernetes. When Chris and I kind of agreed to put together this talk at Spring One Platform, we really challenged ourselves here because quite honestly, we both agreed that we didn't just want to spill out facts and ideas and things like that on slides. You know, we enjoy educating everybody, but we wanted to go a little bit further with this. And the .NET space in Kubernetes is very much uncharted waters. Kubernetes is fairly uncharted waters in itself, right? And so we wanted to try to start thinking about maybe some best practices, maybe some just ideas of at least get this done, get these logs out, things like that. So we've come across some pretty cool things during this demo, and I hope you find some value in doing this. First, the mandatory safe harbor. We're going to say things that you can't hold us to, and hopefully if we're lying, you won't realize it, so it's okay. So first of all, what are we going to talk about? First, I want to quickly review the set up kind of a traditional architecture .NET application. Definitely a legacy application. Let's just kind of level set on this is where we are with this application. Then we're going to take a little bit of a turn and we're going to talk about Windows containers. What is it? What can you put inside of it? How do you make it? Right? That sort of thing. We just kind of want to help everybody understand, demystify maybe a little bit, Docker files, Windows containers, that sort of thing. We're going to get into some Kubernetes questions. As I said, we try to challenge ourselves a little bit and maybe learn a little bit about Kubernetes and adapting an application to it. Chris is going to get into a demo about writing a Docker file. He's going to get in deep on line by line in the Docker files and what it looks like, why he did these things, how he installed the environment, that sort of thing. Then, of course, we'll show you the working example of everything and what it does. And then we're going to extend that a little bit and talk about what it could be, that sort of thing. The one, I think, key point that we held ourselves to during this whole thing is here's the application. Not one line of code can be changed. And we took that very seriously and we followed that through this whole thing. Not one line of code in this application is to be changed. So, the application, super simple here. Fairly traditional, right? We got a whole farm of web servers, Server 2008, running IIS. They have a web forms UI. That's the first fun piece of this. It's a web forms app. Using pooling and all the other natural components of IIS. And then we also have a COM component. And the COM component is installed in the registry. That's how it's registered and available to the application. So this gets really fun really quick using the registry inside a container, no less, right? We didn't change one line of code in this application. This is how it was designed. This is how we want to keep it. But we need to take it off of Server 2008 and we need to put it on modern infrastructure, containerize it, right? That's the goal here. On the back end, we've got the mandatory SQL database. And then the file shares, you're going to see Chris introduce the COM component. It's possibly sharing some files and saving some things in a nice little SMB file share. So first, before we get into the application and all the Kubernetes fun, let's just talk about Windows containers for a minute. As I talk to everyone out there in the world, I spend a whole lot of time, just Windows containers, what is it? How do you install it? What happens there? And I find a lot of folks just aren't quite familiar on that because it's a relatively new thing to all of us, right? So think of a Windows container, and really this is just generally think of containerization. I like to phrase it as a mini operating system, right? That's kind of an odd way to say that, I know. Maybe a little file system is, I think, the right way to do that. But on the Linux side, thinking about a full file system and operating on that, I think is a natural thing. For us in Windows, we don't think of it as a file system. We think of it as an operating system, right? Because we have registries and we have other bits and pieces that Microsoft has put in there. So that's why I phrase it that way, is think of it as a little operating system. The difference is this operating system doesn't have its own compute, right? It doesn't have its own kernel and its own processor and all that. That's shared by all the containers running on the host. And the host is also Windows as well, as we'll get into. It's a full install of Windows. You have a Windows directory, a users directory, program files, all that good stuff. And the reason I say that is because the application, we're kind of just going to trick the application into thinking it's on a full-blown Windows installation by putting it inside the container, right? So all the things that it expects to be there, folder structure, registry, all that good stuff, it's all there. And it can interact with it just as it normally would on a traditional installation. The key point in all this, and I think one of the big points of learning about Windows containerization is, traditionally we are used to installing the operating system and the .NET runtime all at one time, right? And usually the version of Windows that you have pretty much delegates what .NET version you're on, right? 2008 is probably 3.0, 3.5. Move up to 16 and you're going to get to 4.x, and so on and so forth. With Windows containers, we separate the two. And what they've done is the host, the machine actually running containerization, that's a checkbox, a feature in Windows, it's only running containerization. There's no IAS, there's no .NET runtime installed at all. Your container actually establishes the runtime. Chris is going to show you that in a minute in the Docker file. But that introduces quite a world, right? Each container can run side by side, 3.0, 2.0, 4.6, 4.7, side by side on the same host, because the runtime is inside the container. The operating system is just enabling containerization, right? So that is a pretty cool, kind of a mind-blowing concept, right? I can now run one little application, I can install my own version of runtime, and I don't need to be held to everybody else on the server and what version they need or anything like that. So when I got into this and learned these kinds of things, it was a bit mind-blowing doing that. But now, doing things like patching the host operating system, right? Your operators of the platform don't need to worry about your apps. They only need to worry about the compatibility of the operating system and the containerization, and they can patch the operating system, they can move things around and treat those VMs as cattle and not pets without a whole lot of regard to your applications, and it's okay to do that, right? So the whole repave model, those ideas of Windows servers coming and going, that sort of thing, really take shape when you disconnect the operating system and the runtime from one another. So that's the container. Now, the steps for creating a container. This is very high level for you, but I just want to, again, kind of introduce this to you. I want to create a Windows container, and I'm going to do this manually. We're not going to use a CF push to do it or anything like that. I'm going to do this on my desktop with Docker. The first thing is you're going to create you're going to choose the base image. The base image is distributed by Microsoft, Server Core, Nano Core, things like that. The base image has to be compatible with the host operating system. So if I'm on server, my host is Server 2019, then I'm going to choose Server Core 2019. The two have to be compatible. That's a whole kernel thing. We won't go too far with that, but there's the compatibility there, right? So I know my container is just fine with the host. When you're going to write the Docker file, you are going to choose at least a base layer of Server Core 2019, because that's what we're on. You're going to install .NET, the runtime. You're going to install IIS. You're going to install all the bits of IIS, everything that you want, customize it, do whatever kind of magical things to it. And then you're going to bring in your application bits into there, copy in the application, right? We're doing this all in PowerShell. We're doing it in a Docker file, their version of a PowerShell. But what you typically would probably put in a ticket and say, I need this infrastructure. And you're handed back some infrastructure running IaaS with agents and all those good things installed and IaaS pre-configured and all that. Now, we're going to script it out in a Docker file, and it's going to be specific to your individual application, right? So I hope some new doors are opening for you. Some new thoughts here are forming here, because now we're not held to the infrastructure anymore and how fast or slow that may be. Now we're just, here's my container, I'll install everything, let's go. And then the next step, here's my container, I'll install different things, and let's go with that. Once we have that Docker file, that definition of our container, we're going to build it. So that's going to be like a Docker build command. We're going to build a container, get it ready to go, everything's validated there, locally, that sort of thing. Then we're probably going to push it to an image registry. So Docker Hub is an image registry. Harbor, if you're on-prem with VMware, is a image registry, right? We have to get it to an image registry for Kubernetes, because Kubernetes is going to say, where does your image live? And you can't say, on my desktop. That's not going to work out. You got to put it in a registry. Your registry is going to give you a bit of a form of a URL, in some cases a little bit shorter, but it's going to give you the address of where that image is. So then Kubernetes is going to refer back to that every time. Also, when you're putting it in the registry, that opens up doors for some nice scanning and some nice security features and things like that to put images up there. Also, putting base images into a registry, right? We can't download Microsoft's base image every time we want to do this because we don't have those kinds of connections, that kind of access to the outside world. Bring those images in, put them in the registry, and then your Docker files reference those registry addresses instead of something like Windows/Server Core 2019. Very natural thing to go through that. So Kubernetes. I'm not going to get into teaching you about Kubernetes and teaching you about clusters and all that. I wanted to, but he said I talk too much, so I can't. I just want to give you some points of view. And this is honestly, these bullet points were some of the things that we got challenged with in using Kubernetes. And I think one of the biggest ones that come to mind is, do you use namespaces or clusters? What's the difference? How do I choose that between the two? There were questions like that about, I want to use this thing, but where's the best practices for it? And we really couldn't find much of any. The tenancy model, using clusters, using namespaces, using selectors, things like that, we had to visit these thoughts. I'm not going to give you best practice on that, honestly, because it's per installation. It's per choice. If you need dedicated infrastructure and things like that, or you need PCI, you have PCI compliance, or you need really, really good isolation, then you're going to be looking at clusters, right? If you don't, if you just need kind of an org and space kind of model, like Cloud Foundry, then you'll probably be looking at namespaces and stuff like that and just use shared infrastructure and all that. But it's how your Kubernetes, your PKS installation has been made available to you. There's a lot of factors there. When you're choosing Kubernetes, you're going to bring your own container to there. Maybe some elaborate pipeline or things like that to automate that. That's nice. But when you're using Kubernetes, expect to write your Docker file, define the container, and you're going to bring the container to the platform. And I say that in that way because with Cloud Foundry, you bring your app to the platform, and then Cloud Foundry containerizes it and does everything. Not the case here. Kubernetes is a container-based platform, so you have to do all that work. That's a little bit of debt, right? That's a little bit of overhead for you. Let's make sure that we're making the right choices, and we can justify this by the business of taking on this debt of having to manage all the images and the layers in the Docker file to use Kubernetes. As opposed to Cloud Foundry, where you do the CF push, you're going to get your route, the load balancing, all the fun stuff that happens there, it's just handed to you, and you get a nice DNS name back to you. In Kubernetes, you can wire up DNS for sure, but you're going to have to tell Kubernetes, I want this to be publicly accessible, and here's what publicly accessible looks like. Kubernetes is going to give you a port number back for that. So there's a little bit more kind of raw wiring up there to do as far as routing and things like that. Again, this is a choice that we made, right? This is the right platform for us, so we're okay doing these kinds of things. Persistent disks. So this is a little bit of a difference from an app platform where You need to be sessionless. You need to be stateless application because you're going to get moved around a lot. So you don't really have a disk that you can ever write to. In Kubernetes, we actually do introduce the notion of a persistent disk, and you can have long-running tasks and things like that. And you can attach your application to a disk that maybe follows it around to the different places that your pod may get scheduled and things like that. So some nice features there. We can do long-running processes in Kubernetes. We need to take some things into consideration there, but you definitely have that option. Also a part of this, right, we want to do this in a modern way. Just because we're taking this terrible old legacy .NET application over to modern infrastructure doesn't mean we can't make good choices along the way. And in fact, that's where we want to start, right? We want to think about like 12 factors and things like that. We're not writing code, but that's okay. There's still a lot of factors there that we could apply to this. So container everything. Right, that was the first thing. Everything goes to a container here that we could possibly put in a container somehow. That is just a modern way of, I think, thinking about architecture and such. Automate everything. We want absolutely everything possible to be automated or somehow be scriptable in a pipeline. No manual acts here, no sending your files over the wall to some directory who someone else copies it on to this other place who goes this other place and all those terrible things. Automate everything all the way to production. On Kubernetes, to get any amount of logs at all, you must be streaming them out. That means console.write to most of us .NET folks. You must be streaming them out. There's IIS logs, there's app logs, there's event logs, that sort of thing. We need to get all these out. They must go to, you may heard it as a standard out, but they must be streamed out of the container, thus out of the pod, thus Kubernetes will pick it up, and all these magical things happen. But we got to keep ourselves to that. Loosely coupled services, right? I can't be hard bound to some service at this IP address, at this place. I can only get there, and if this isn't there, everything goes out the door. Right? These need to be loosely coupled. My application may get rescheduled, meaning the pod may get moved to another cluster or another worker or something like that. I need to be resilient to that. So I need to be able to change my connection strings on the fly, things like that. I need loosely coupled services, backing services for it. We're going to assume failures. I'm going to assume that my pod is going to get moved around. I'm going to assume that things aren't going to work. In this. So I need to write my Docker file. I need to think about my environment around this application really, really, really well and assume that things are going to break and not be there, and my app can't freak out because it's a legacy .NET app. If things aren't perfect, it's going to freak out. So I need to make that resilient. I need to insulate it somehow from that. I want it to be highly available. We're going to get a little bit quick here. I want it to be highly available, and I want it to be cloud everything, right? I want the application to be scalable. I need multiple instances of it. I'm only going to be able to go so far with that because it's a web forms app with a COM object. So not a whole lot of scalability there. But I also don't want to have to create 50 servers, to be able to house my work or anything like that. I need it to be scalable. I need to go up in instances, and I need to go back down in instances in the most reasonable way I possibly can doing this. So I'm going to throw this one in here. This is my obligatory pivotal plug here for all our products and all that. But I think that this is a great way of thinking about an application platform and a container platform, and what kind of choices I'm making between the two. They're good. They both have a place in this world. They both have a place in most enterprises. We just have to choose what the right one is. Saying that we're going to containers, so we're going to use a container platform is short-sighted. And you haven't done your homework about why you use the two. You're still going to containers both ways. Windows containers on these two look the exact same. The operating system is the exact same. It's how you got there. What kind of overhead are you putting on your developers to get there? And the expectation of your developers versus the expectation of your platform team and all that. Those are the choices that we're making. So I thought that was a good way to summarize that. Okay, I'm going to stop talking now. And Chris is going to get into some Docker files and show you a little bit of code.
All right, thank you, David. Now that we have the marketing guy out of the way, we can get some work done, maybe.
He has to sneak that in, yeah.
So the first thing that we're going to talk about is basically Windows containerization in general, and to try to get you a bit of an intuition as to what actually happens when the magic happens underneath the words that David laid out for us. So I have a simple example here. We'll start to talk about things like COM and complex scenarios later, but we'll just start with a simple, very dirt simple web forms application. And we're going to, if I just go to the right guy here, we're just going to assume that we have kind of a little bit of a one-pager, and our goal is to containerize that, and at least run that Dockerized. We'll talk about scheduling that somewhere later, but just get this wrapped in a container so that we can push it to a registry and run it where we like. And for an application that is this simple, just a plain web forms app with no integrations, the Docker file that you need to accomplish that is about as simple as the app itself. This Docker file that you see here is a realistic example of what you would do to solve that problem. We have a base image that Microsoft provided. We didn't build that base image. It is the ASP.NET 3.5 base image because that's what our app happens to be. And because IS is going to run our ASP.NET web application, we are going to expose port 80 of the container. That does not mean we're going to use port 80 of the host that runs this container. The container just exposes that port, and then whatever that orchestrator is going to probably do some mapping to give you something that's actually exposed to the public. And then that just kind of sets the stage to say what we're going to build on top of. And then, of course, we have to copy our bits into the container itself, into the image itself, and that's what we see down at the bottom. That is, copy our app into something that is based on ASP.NET 3.5. Now, like I said, this Docker file is realistic. It does a pretty good job of telling you what you would actually do in the real world, but it doesn't do a good job of getting you an intuition as to what's actually happening under the hood. Really, this ASP.NET base image that Microsoft made is in turn based on a .NET runtime image that Microsoft made that is in turn based on a server core image that Microsoft made. We never had to worry about that. But that layering that I mentioned is a key component into how Docker works. And you, in turn, can do things like create base images that you could layer your own bits on top of. Now, I'm going to now show you a Docker file that is probably not realistic, but it is functionally equivalent to the first. This Docker file basically takes everything that Microsoft did in all of those layers and just shows it to you in one Docker file. And here's where we do things like installing the .NET runtime into on top of our base image. We're going to do things like install IS into our image. And you'll see this kind of thing maybe in some of the Docker files that you build, where you'll install some Windows features, add some Windows features, in this case, IS and ASP.NET. We're also going to install some custom Microsoft bits. You can see that as just putting EXEs, dependencies, things that you have into your base image. And then we're actually going to configure IS in some way. You could think of, anytime you go into MMC in your IS configuration and do some kind of like settings on your app pool that are necessary to make your app work, you don't have MMC and an IS GUI in your container. So you have to do these things from the command line. And appcmd gives you a facility to do that. And you probably see if your images are anything other than simple, you'll probably see a fair bit of this. And again, as is typical, we have to copy our bits into the container and run the darn thing. So these are functionally, like I said, functionally equivalent Docker files, but this simple example is what you'd probably actually see in the field. And This is more of an example of the kind of tools that you might need to use in your complex scenarios.
And let's take one moment there and do a little break on security, right? Every single layer in a Docker file represents a patchable thing, right? In this case, we put IIS in there, we put ASP.NET in there, we put a base image of server core in there. Every one of those is patchable. That's a lot of overhead, right? We had 3 images there just to get going on a base ASP.NET application. We had at least 3 layers right there. Who's managing that? Who's patching those? How often does it happen? Do you have to completely rebuild the entire container image to patch one of those layers to then get it back up on your platform, right? There are a lot of complex choices and things to be done there. Cloud Native Build packs that project, begins to answer some of those questions about replacing layers and all that. But these are the kind of questions, right? When I say choose a container platform, choose Kubernetes and things like that, you have now chosen to manage all of those layers of the application, right? Because we're not going to go. An application platform is going to take care of all that for you and do it in a zero downtime way. These are choices that we're making.
And last point before we switch over is that as you see all of these run commands in this Docker file, these are PowerShell commands that are being run inside of a container that's being built. They're not run on your host OS. So you can think of that as the build process that gives you a shell that is non-interactive. And kind of think of the Docker file as a whole as a recipe that builds images. It could be a human that writes the Docker file. In this case, I wrote this one. But there's also other tooling, things like Draft that Microsoft had. I mean, even Visual Studio can generate Docker files to some degree. But this is a recipe that builds an image, and an image is a layered file system that you can later turn into a running container.
Cool. All right, thank you. Now let's get into, now that we've kind of talked about containers and all that stuff, we'll get back to the topic at hand, and we'll talk about moving this application in. What does it begin to look like? So first, the basics here, we're on Kubernetes, so we're going to be working inside clusters. So we have a cluster. When we get a cluster, we also most likely are going to get a load balancer of some kind. Again, I'm not going too deep on Kubernetes and all the bits and pieces of it. These are just, high-level constructs for it. Inside a cluster, we're going to have a worker, whether that be a Windows worker or a Linux worker. Those are true operating systems, right? A Windows worker is running Server 2019 on it. Inside the worker, you're going to have containers on there, right? Kubernetes actually introduces the notion of a pod. And inside a pod is a container, because the pod is what enables Kubernetes to schedule, control, run, what have you, that container. When you're talking about Kubernetes, I see a lot of people just use the word container and pod synonymously between the two. Technically speaking, they're not the same thing. You could run multiple containers inside a single pod if you like. In our case, we're just running one-to-one there. But we need to be clear about that, because the pod is what creates things like config maps and volumes and that sort of thing. Config maps are how Kubernetes is going to effectively do the service binding. That's your environment variables, right? When you do a service binding, you're exposing environment variables to the container, and the app in the container is expecting to get those values to then do its thing, right? That's the binding happening, and so config maps are how we do that in Kubernetes. So we have our Windows container inside of here, and our Windows container is going to have IIS installed, the web forms UI, the COM object, that sort of thing. So given where we were in our traditional architecture, given what we just kind of went through learning about containers and all that, this is pretty natural, pretty plausible thing, right? We just took the application and moved it right into a container. Do that. If you don't believe me, Chris will prove it in just a second anyway for it. We left the database and the file share where they are. There's really no reason to move those right now, right? In future iterations of this, we could get into, as we'll show, moving the database into maybe the cluster, maybe a different pod, that sort of thing. moving the file share, making a persistent disk, or things like that. We could do some cool things there, but we're about the application right now and getting it into the right place. So let's look at this now that we kind of understand the architecture of where we're going, and you see the pieces that didn't have to change but got wrapped in a new environment and all that. Let's see the Docker file behind it.
Yeah, so I have another example that is relatively similar to the first, except it has a couple of wrinkles that were added to the situation. If you look at this project, we can see that this is a application that requires a x86 underlying CPU architecture, and there's a reason for that I'll talk about in a moment. But it's also a web forms application, ASP.NET 3.5, so it's still an old application. And what this application does, it's kind of a cool application, I think anyway. I'll actually give you a little demo here. Is it allows you to watermark an image. Basically, you upload a 24-bit bitmap, and it overlays a 1-bit bitmap on top of that is the watermark. And let me just give you a little demo here. Has to upload that file into the container, do the watermarking, and here you go. And what I really love about this application is it lets me put my own personal seal on an image.
He's been sitting on that for days.
I have been. It was so hard to keep that one under wraps. But the application itself, the ASP.NET web app, again, kind of single pager sort of deal. Does a little bit of local disk I/O, and these are things that are going to happen inside the container itself. But you could imagine, insert file share access here or Docker volume access here. We're just going to stick with the local file system for the moment. And probably the meat of this application, the thing that makes this interesting to us in a demo, is that we have a COM dependency that is the kind of thing that could trip up a lot of PASs, frankly. I call it Aquamarker here. It's a C++ ATL COM library that does the watermarking. I happen to have the source code because I wrote it, but you could imagine that you have some third-party component, something some other developer wrote and lost over time. But we're going to approach this as having a 32-bit COM DLL that's going to require a 32-bit app pull in IS. And then we're going to do a little bit of logging and display our sealed image to the screen. So from a Docker perspective, what is that going to look like? And there is some meat to this Docker file. Some of this may be confusing at first, but I think it's going to give you some appreciation, maybe even for what you can see in some PASs, some things that we have to worry about in putting this Docker file together that maybe we wouldn't if we had something like a build pack kind of taking care of it for us. But we're going to expose port 80 from the container because we have IS yet again. We are going to download and install the C++ redistributable. And you can see with the add command that adds files into the container. You can give that URLs that it'll fetch and then put into the container, or they can come from the local file system as well. Kind of pick your poison. We're going to then run the installer. That's the kind of ugly thing that you unfortunately do have to do on occasion when you're putting these together. It can be running MSIs. You need some kind of an installer that is going to run from the command line or be able to run from the command line. And that can actually get kind of tricky. But we're going to put our COM library, our 32-bit DLL, into the container and do the registration. And note that we are specifically using the 32-bit registration for our library. And I mentioned how there is the need to configure IS when you don't have your nice MMC snap-in. Well, we have to allow this app pull to run a 32-bit application, and that is not an IS default. Luckily, appcmd can save the day, and we'll use that to configure the app pull to allow 32-bit apps to run in 64-bit pools. We'll copy our bits in, and then another interesting pattern is that it just so happens this application does the writing for both the unwatermarked and watermarked image to the local file system inside of its images directory, basically. That's something that by default you don't have permissions to write to. So at the time the container is being built here, where we're running as an administrator, we're going to grant access to IS to write to that directory. And then I'm not going to go into it in depth, but the logging within Docker and into Kubernetes, as David mentioned, does have a similar flow to what you'd expect from like Cloud Foundry or something to that regard, where if you go to standard output, things stream through a log stream. And when you have things like Windows services or say a collection of services or say event log, it is up to you to make sure that those things get to standard out. And you kind of have to piece that together a bit. So I have a little bit of kind of custom code to make that happen. In this case, we're using nlog to shove them into a predictable place on disk, and other things to shove them into that predictable place on disk. And then the entry point for our application is going to emit those to the console. And to rewind a little bit, that's actually an important concept, is the idea of an entry point. The entry point is the process that is going to run in the container that allows the container host to know that the container exists and is running. That doesn't have to be the only process or thread that's running in there. If you look at our original example, you'd see that Microsoft gives you a nice service monitor that you can use to kind of latch on to a running Windows service. In our case, because we're going to do some custom logging business, we'll write our own in that PowerShell script. Now, we're going to kind of take for granted that we've built a container. We've used that Docker file, which is a recipe for making an image. We've then pushed that image to a registry somewhere, kind of take that for granted. And then we want to run it on Kubernetes. So how do we do that? Well, this is where our old friend YAML comes to the rescue, which I know everyone's probably very happy about. Here we have both a deployment, and I'll talk about service descriptor YAML, that's going to tell a Kubernetes cluster how to deploy a containerized set of services or application. And in this case, this is the name of an image that I've built from that Docker file and pushed to a registry, Docker Hub in my case. But we're going to tell Kubernetes, please run one. I can dictate the number of replicas that I want. I'm going to say run one of Chris's Aquapage image. And then I'm going to have to tell Kubernetes to make sure that you run that on a Windows worker. By default, Kubernetes is likely going to try to schedule things on Linux. This will most certainly not work on Linux. So we have a little bit of magic down there to make that happen. And then we have a service definition down here, which is going to tell Kubernetes to actually expose this container to the outside world in some way. And this is, we're not going to go through all of the possible kinds of services there are, but this node port is going to say, take port 80 from the container, which we know the container is going to expose something on 80, and then map it to some node port, some port on the actual worker node so that we can consume that. Probably the simplest kind of service. There's also load balancers and all sorts of fun things, but we'll get to those later. And let's see if well, since the dashboard crashed, I'll just do this the old-fashioned way from the CLI. But I've taken the liberty of deploying this application already up to a cluster that David graciously created for us. And you can see that the Aquapage service is right now running up on our cloud. So I can.
And so as Chris goes through this, we're feeling very manual here, right? CF push, you never saw these kinds of things, IP addresses and ports and all that. It happened in the background, but you never really saw any of that. On the Kubernetes side, when you deploy the pod, you're going to have to get the IP address, not of the container, because that is completely within Kubernetes and not accessible outside the cluster. You need to get the IP address of kind of an entry point to the cluster, which is the IP address of the nodes, the workers running within the cluster. And then you get the port number, put those two together. That is your actual mapping to get down to the container for it.
And it's nice if you use a load balancer, you just create that, grab a URL, and you go. But here we have our app running up on our KH cluster. Same application, it's just now scheduled somewhere else. And we can test it out. This time we'll use a slightly different bitmap, and it's going to this time have to send it to probably California, I think, and then it's going to come back. And here we go. We have a sealed Kubernetes logo.
Seal on the approval, yeah.
But just kind of a final point, we can ask Kubernetes, kind of what is your state? Is our pod up? Is it not? How many of them do you have? And here's our Aqua page, and one of one is running, so everything's happy.
Cool. So, I think one of the key points about between an application platformer, specifically PAS and PKS. In PAS, when you CF push your application, in the background the containerization is happening. It's running in the context of a very, very locked down custom user called vcap. That user cannot get to the registry, it cannot get to the disk. You are very locked down. That user, the base image of your container has been chosen by Cloud Foundry, what it is. All you're showing up is with your application in there. So you can't do a lot of edge cases there, right? You can't do a whole lot of customization, bin deployable, those kinds of things. It's got to be basically coming out of Visual Studio if it's going to work. No PowerShell scripts and just like that. Just a second. Whereas on the container side, you are container admin because you're scripting that Docker file. And as container admin, you can do all kinds of fun, crazy things like Chris showed you for it. So as we continue through this, sorry, question?
Yeah, what if you have a process that you want to run in a container that needs elevated privileges?
You need to be container admin to do it. So if you get into those kinds of situations, an app platform probably isn't going to give you the opportunity to elevate permissions or anything like that. So you're going to be looking to a container platform to be able to do that. As a container platform, writing your Docker file, you can actually script, create the user, add them to the administrators group, do those kinds of things. Now, to be clear, you would be adding a user to the administrators group of the container. The container has no privilege at all to talk to the host. That's a one-way thing. There's no notion of privileged containers in Windows, by the way. That's not a two-way street there. The host can talk to the container and control it. The container can do nothing with the host.
On purpose.
Yeah, on purpose. Right, okay, so we'll keep track of time here and think about extending this a little bit, right? We've taken our application from the traditional stuff, we moved it into a Kubernetes cluster. I think we showed the steps along the way. I hope that was pretty clear. What else can we do with this? Again, without ever changing a line of code of the application, getting into the cloud everything, the high availability, getting those ideas. Now that we're in Kubernetes, now we can use all the wonderful things that they give us. So something like scaling clusters. Maybe these clusters are in different data centers, right? Maybe we've manipulated that. Maybe they're geolocated and things like that. And our application can move between those different clusters possibly. Maybe we have pods as well. Maybe we schedule the pods. You saw in the YAML manifest, you can set the number of pods that are done. So the application is relatively stateless, right? It's just processing an application. And the store that would be behind it, if we weren't writing to disk, the store behind it, that file share, that is not being replicated, right? That's a whole separate thing. That's why we kept it outside of the Kubernetes installation altogether. So our app can actually run multiple instances, and we can get away with it pretty well inside different pods. So we can schedule many pods, right, to scale out. Now, we could also use some nice things that Kubernetes gives us, like persistent disks, and get into, well, our file share needs to go away as well. It was probably on Server 2008 as well. So let's actually move that inside to a persistent disk. So if you're on vSphere, that's like in the form of a VMDK disk. So now that's managed by vSphere. vSphere can do some really awesome things to make sure that disk is always available and always up. And then we can take that and mount it to the container. And the container sees it as a directory, c:/mymount, right? Something like that. And so the application itself really doesn't know a lot of difference there between whether it was on traditional architecture and some dedicated file store or manipulating things around a little bit. Also, we'll wrap up here. I also want to give a honorable mention to my friends over in Steel Toe. If we did have the option to modernize the application a little bit, maybe, right? That COM library, we probably couldn't touch that. Chris is right, that's probably some third-party thing that we can't touch. But the application itself and what it's using, maybe put a cache in somewhere, things like that. We could have grabbed our a couple of Steel Toe libraries and brought those in and made our life very, very easy should we have the opportunity to get to the source code and recompile. And I think that's worth a mention here, using Steel Toe, even with the .NET Framework app, to make our app look somewhat like cloud native-y or moving in that direction, trying to fill some of those factors for everything. Right? So, I hope we've painted the picture for you. Any questions? Everyone's always available. We'd love to hear from you. Please.
I don't know if you guys have tried using the packed lightweight, the open source pack. If you use it and just create the image directly from there, will it work out of the box? Like, create that image in the registry and try to use it? Is it going to work?
Quite often, things that aren't obvious, anything that isn't obvious about the application that's being inspected, it's going to miss. Draft was the same way. So it works fine in an awful lot of cases, but I would certainly suspect that in the long run, even on the Docker side, people aren't going to have to write Docker files by hand for long, right? And they often don't today.
Yeah, that being a part of the pipeline, that's a very reasonable thing to do that, automate that.
I think if you think about like the work that Pivotal is doing with cloud native build packs, essentially is kind of that idea where we take the design of that containerization away from you, so you can just give it an application and get a working image.
Questions, thoughts? Cool. Let me give a quick plug to the next session. Genevieve and Grima are going to be talking about all things Windows on Cloud Foundry. You may know it as PASW, that sort of thing. They're going to give you a little bit of update there, what we've been working on, where we're going, that sort of thing. So please stick around for that, because they've got some pretty cool updates and ideas and such. All right, guys. If you ever want to talk about Windows containers, because I know it's a lot of fun to talk about Windows containers, or Windows workers, or how they fit in, or making these decisions about app platforms, container platforms, what's the right choice, how do I look at this, best practices, all that kind of stuff, please find us, please look us up. We're always around, always happy to help and just sit and talk with you about all this stuff. Thank you.
Thank you.